known universe, galaxy clusters. Now, the universe consists of billions upon billions of galaxies distributed in the so-called cosmic web according to gravity, the same force that keeps the moon around the Earth around the sun, and me from casually flying away. Now, in some regions of space, namely the intersections of this web, galaxies will tend to group together. They will begin to orbit around their combined centre of mass. And these orbits are what we call bound. That is, like those of the planets around the sun, the galaxies do not all just crash together, but equally they do not just fly off into space. When such a group is big enough, we call it a cluster, and being bound, they are the single largest true object anywhere in the known universe. However, there are, of course, complications. Not least when we consider that surrounding the galaxies is an enormous amount of extremely hot X-ray emitting gas. Now this gas should, over time, be expected to just sort of fall down toward the middle, cool up, cool down. Fantastic. Except astronomers are a discerning lot, and went and had a look, and they found significantly less than you'd expect. And so it became clear that something was counteracting the cooling. So, where is this energy source? Well, let's consider 3 facts. Fact 1. Every large galaxy in the universe has at its centre a supermassive black hole. Fact 2. The bigger the galaxy, the bigger the black hole. And fact 3. More often than not, at the centre of a galaxy cluster, you will find sat in the middle, going nowhere, a brightest cluster galaxy. This is just one humongous single galaxy, larger than any other. Chiefly, of course, they then have the biggest black holes in their centres. They can weigh upwards of 1 billion times the mass of the sun. That's a huge energy source just waiting to be tapped. So how do we get the energy out? Well, black holes sound like an exotic, weird, complicated thing, but really, in principle, all a black hole is a region of space where you shove so much stuff, so much matter into such a small area that once you're within that area, the gravitational field is so strong that nothing, not even light itself, can escape. Fantastic. If nothing can get out, how do you get the energy? Glad you asked. What happens is that the hot gas, as it falls onto the black hole, as it accretes, as it gets sort of close to it, it's exposed to huge gravitational potential. And what can actually happen is the mass itself can release some of its stored gravitational potential energy. And what we find out here is that if you convert some mass m into energy E, famous equation, we need to multiply it by c squared, speed of light squared, a massive number, namely an enormous amount of energy is released. This goes into heat, into light, but importantly, it also goes into accelerating charged particles up towards very close to the speed of light. These, as the black hole spins around, it twists a magnetic field. These charged particles are ejected along these, and what we see is that as the charged particles spiral around the magnetic field lines, that they emit radio waves, which astronomers such as myself can then go and see. And we see these lovely, in the red here, jets. Essentially what these are doing is blowing huge bubbles into the hot gas. And it is the action of these bubbles that, just as bubbles do, rise buoyantly through the atmosphere that take the heat from the black hole to the environment, stopping the fall.